Howdy folks, so welcome to part 3, and today we're going to take this chassis out and see the underside, because I'm pretty sure that's what everyone wants to see. So, for my own documentation, not that you can really screw this up, because I think all of these plugs are coded, they're all keyed. So this is the phonograph power here, and this is the remote speaker, which is really stuck on there. It's probably never been removed. And we've got the phonograph left and right at the top, and I've marked which is left and right already, because I don't want to have to deal with figuring that out again. Power cord is attached, and I've got to take that screw out there. That's the grounding for the turntable. They just screw it into the transformer there. Which, I mean, ooh, that was a... did not mean to do that. But the tube did not shatter. So I think I'm okay. Damn, that one wire is really nasty. It's all disintegrating and marks everything up. Okay, so to get this out, the face on the top is part of it. So all I need to do is disconnect the antennas, which are, that's the easiest way to do that. I'd think the easiest way, because I've got to deal with that. I think I'm probably just going to take the terminal strip off, just take these two screws out, and then take this FM1 off. And then there's 3 screws along the bottom, and I can't see anything on the top. Let me take a look. So here it is. I got it out. And when I say drop the chassis, I really mean drop the chassis. There are 4 screws that hold the chassis onto this metal plate here. Once those 4 screws are gone, the only thing that held it on was the knobs. I forgot to remove the knobs. As soon as I pulled the last knob off, it basically fell right out. So I'll actually have to take this out and clean that. So there we are. So as you can see, obviously there's a lot of cleaning involved here. There's some electrical tape here. Now it's very old, could be original. Most likely this is just the light bulb is under here that illuminates the dial. So I'm assuming that that's just what that's for. When I'll take it off just to inspect underneath there. It may have been repaired at one point because it doesn't look factory to me, but it probably happened quite a while ago. So here we can see we have our 2 6 GW8 power output tubes. These would be our 2 audio output transformers, 2 mains filter caps, mains power transformer, our oscillator, our tuning capacitor. This is our AM converter, and then we have our IF stages here. I think that's the detector. I have to refer to the service schematic to remember exactly what goes where. We have our power outlet and the phono power, the speaker output, and there's a circuit breaker here, which is quite nice to have instead of a fuse. This particular unit, you'll notice that there's no rectifier tube, and that's because, if I remember correctly, this is technically a hybrid unit. It will have 2 semiconductor diodes inside for the for the rectification. I'm not sure if they're going to be silicon or germanium, but let's flip this over and take a look. This chassis really sucks to work on just by design because you can't really prop it up against anything. I mean, the dial cord runs along the one side, and you've got the AM bar antenna, so you can't really lean it on anything. It's kind of shitty just to position it anywhere. But here's the underside, and this is the first time I'm seeing it. So first of all, I don't see any bumblebee capacitors, which is nice. I do see what look like some ceramics, which is understandable given how this unit's still operating. We've got looks like some paper capacitors. So let's see where the power comes in is right here, and there are our two diodes right there. Fortunately, the light's a little too bright, so you can see them right there in their metal can. I'm gonna have to test those and see if I can find out if they're germanium or silicon. I have a semiconductor analyzer, so I'll know exactly the specs of those things, because they're not really marked on the schematic as to what they are. So we've got some. We do have some issues that I can see straight off the bat. For example, right in the center of the screen there, that resistor has split right down the middle. That's probably wide open. So that'll have to be changed. That resistor right there looks like it's gotten toasty, just in comparison to the other ones around it. So I'm going to have to go through this, and I'm going to test every capacitor with my capacitance meter, ESR meter, make sure that they're okay. Anything that's leaky or stuff like that, I'm going to just change. I'm not really too worried about replacing all the caps. If I have to, I will. The resistors, I'm only going to check the ones that look suspicious, because there's far too many on here, and I mean, only if there's an issue will I go searching for bad resistors and stuff like that. Other than that, I'm gonna, clean it up, clean all the pots and stuff with contact cleaner, and all that kind of stuff. One thing that I must say I like about this chassis, or at least that I think is interesting, is that the radio module is exactly that. It's a module. You can see this box that's screwed in by actually like anti-vibration bushings on this side, one on this side, and then there's two on this side, one in each corner. And it's like it's just really interesting. It had a metal cover over this side right here. So obviously there's some very critical stuff. This is obviously where the front end is. But yeah, I think this is really cool that they have a shock-mounted radio module in this thing, and the oscillator is separate. The oscillator is this right here. It's an interesting construction. Most stuff is really highly integrated, so for it to be modular like this is it's new for me. So let's just check that split resistor there and see what it measures. So first, let's measure the one on the other side here, the one that we know is good. Well, I shouldn't say that. The one that at least looks healthy. And that reads 153 ohms. And then let's measure the one that looks like it's exploded, 228 and falling. That's a capacitor that's charged. So it's high, but wow, I would have expected that to be open. Unless it's the capacitor that's holding it. I'll have to take it out of circuit, but wow, I was not expecting that. So I just hooked up my transistor analyzer to one of those diodes, and let's see what it says. This is in circuit, so this could be interesting. Okay, so it says it's a Zener diode. I doubt it's a Zener. I think it's just a regular diode, but this is probably the in-circuit effects. Interesting. So that would suggest that it's a silicon diode with a forward voltage of 0.6 volts. So yeah, it probably is a silicon diode. Let me check the other one really quick. See if that one gives me the same same result. I think I got them clipped on all the way. Yep, Zener diode. Again, 0.54, yeah. So these are definitely silicon diodes. That's pretty cool. So let's just go through and just check some of the capacitors really quick in circuit with my capacitor tester ESR meter. So let's start with this this electrolytic here. Okay, that ESR is pretty high. I know that a lot of people are going to be arguing that ESR doesn't matter for a lot of these capacitors. Obviously the ones in the audio do matter, but ones like probably like this, which is a tank capacitor, ESR, oh, it's not switching, it's not very fast, it doesn't need to... No, I'm going to change it if it's... It basically, if this thinks the ESR is too high... Actually no. I'm going to make my judgment call, but 25 ohms is a little high. And I know that there's nothing in series with this cap, so it's not like there's a resistor or something that I'm reading. The ESR of that cap is truly just way too high. My meter won't measure everything. Yeah, see, it'll do this a lot because this doesn't measure really small capacitances, which I think a lot of these probably are. So basically, if I can't measure the capacitance with my meter, I'm just going to assume that it's bad. This I expect because it's a resistor in series, so there's going to be a lot of desoldering and resoldering to get correct values for some of these things. Just notice this component here, this red one. I'm not entirely sure what this is. It's got 3 terminals. I mean, it looks like a capacitor, but... I'd have to check the schematic to see what that is. That's interesting. Well, I just remembered, I think this thing had a semiconductor component in the FM stereo adapter. And yes, we do. We have a very strange diode block here. Let's see if there's anything in between the other terminal. No. Only between those two. And I also noticed that there's actually another one. There's another one which makes me believe that this is some sort of thing to do with stereo again, because there's actually 2 of them, one for each channel. So let's test between those 2. There we go. It's giving a ridiculously high forward voltage though, 8.5 volts. That seems excessive. So let's see what this one should be identical if everything's working correctly. Yeah, and this thing can't find it. So it might just be that I wish I could find I wish I had the schematic with me. Let me go get that. I think it shows this is a dual diode block or something like that. So here I have the schematic, and I apologize for just filming my screen here, but I'm not going to bother with screen cap stuff for this. So this is the PDF version of the schematic, and this is the FM stereo adapter, which is the component where I saw those weird devices. And here they are. There's two of them, two dual diode devices in the schematic, and they've got a little picture of the device here. And I remember there's this little notch on the top. So it's two diodes. They both face the same way. So technically, it's through the diode from one lead to the middle, and then out. Now I was measuring across here, and my peak transistor analyzer would detect the diode with a ridiculous forward voltage across here to here, but it would never pick up anything from here to here or here to here, which I think is a little interesting. And this is just how Peak's detector works. I mean, it probably, whatever this is a very strange diode, definitely. I don't think I've ever seen one of these devices before, but that's where you can find that in the schematic. So we've still got a detector here. Yeah, I haven't studied this. This is not a self-powered unit. Obviously, the detector or the FM stereo adapter is built in, so this power supply with the 6x4 and everything is not present in my particular model. So there's a string instructions for the dial cord, which is actually correct for my model, and this is not given on the piece of paper that's stuck down. Which is nice, so good to have that. This is the same diagram as what's in the actual chassis itself, so you can see these are all of the other names of the radios that were that use this chassis. I do have alignment instructions, although I don't have a signal generator that's capable of generating the frequencies required to do an alignment, so I'm gonna have to just go without aligning it for now. And of course I have the amplifier section here. So obviously we've got the inputs over here, our selector switches, and we've got the 6GW8, which is a dual device. We have a triode and a pentode, so you can see each channel individually in class A. We have our output transformers here, and then there's that socket that goes to both the remote speakers and the built-in speakers in parallel. This is where I got the 2.5 watt output rating from in my first video, 8 ohms. That's where I got that from. And the power supply is right here, and those are those two devices that my transistor analyzer said were Zener diodes. They're probably not Zeners, but that's where they sit in the power supply circuit here. You can easily get this online if you just Google the model, the chassis number. You can find this relatively easily. And this is the tuner section. So this is the mono tuner, which still uses a 6AL5 as the detector, and you can see it's got 3 IF stages and 2 limiter amplifiers, and then we've got the AM converter, which is down in the corner on the chassis, and it gives a bit more alignment stuff. So yeah, I'm gonna go through, so this weekend I'm going to go through this and find all the capacitors that are non-ceramic, check them if possible, and I'm just going to try and make up a big list, and then I'll order them from Mouser or Element 14 or DigiKey or wherever, and hopefully they'll come in within the next few days and I can get to replacing them all. Well, I was just checking for capacitors that need to be changed, and I took the crossovers off of the speakers inside, and these are just 5 microfarad 10 volt capacitors, and their ESR is a little bit high. They've actually maintained the value, but their ESR is a little high. The reason why I think these are important is because this brand, Hunt's, they had the courtesy of providing manufacture date, July 1964. And so I checked the other one on the other side. And it says, if I can get it the right way around, it says June 1964. So what that tells me is that this was made at least July 1964. The month is indeterminate, but I would have to say it was definitely made in the second half of 1964. So it's not 1960, so obviously that marking on the chassis is not a date code, it's something else. So at least I have a manufacture date, which is good. If I come up with any newer components as I'm taking things apart, I'll update the date. But until then, I think 64 is we definitely have a real hard date now, which is good. So new updates regarding the date. So I looked closer at these two diodes in the power supply, and I'm not sure if you'll be able to see this because it's all the way underneath here, but they say 6447, so that's 47th week 1964, which dates this to late November 1964. So definitely later half 64. With that kind of date code, it's even possible it would be very early 65, but I'm going to go with 64 for now. But yeah, the date keeps getting newer and newer as we look at more and more parts. One of the things that I didn't mention, and just want to make explicitly clear, this radio is 100% original. I have looked around and there is not a single component which has been changed with a modern equivalent that I can see at all. In fact, apart from the at least one of the tubes, one of the 6GW8s has been replaced. But other than that, which I expect, of course, given a radio with this many hours on it, nothing has been changed. This thing, in fact, doesn't even look like it's been serviced at all. So that's pretty amazing. 51 years without any modifications at all, and it still works as well as it did. I wasn't really sure what kind of quality I'd expect from Electrohome. I knew they weren't a crap brand, but I knew they probably weren't like Zenith or anything like that. But I'm actually very impressed with this. Even though there's a large number of disc capacitors and things like that, I'm not bummed out about that. You look at the schematic; they're all specified to have a certain tempco, so they only drift so far, and that's probably what's led to the reliability of this over the years. So yeah, I'm not upset about that at all. I know some people think that ceramics are generally cheap, but I don't think so much. So yeah, I'll be the first person to work on this in probably over 50 years. So I just thought I'd take off the other metal shield here. I remember there was one down here. There's also that one over here, so I just took that off, and now we can get a better look at the FM stereo adapter module, which is built into this radio. So you can see how it's got the 4 screws in each corner, where this would have been an optional addition they would have added to certain models. And in other models that didn't have this would be replaced with probably just a blanking plate with 2 phono jacks or 2 RCA jacks, and you could then buy this as a separate module and plug it in, and that's how you get the stereo demultiplexing. One really neat thing that I haven't really seen in many radios is the fact that they've used coaxial cable. In fact, in a large number of places. For example, this white cable, as you can see, is a dual coax that goes up to the selector switch here. The turntable leads, for example, they were coax. It looks like they paid a lot of detail to signal integrity in this product. You can see right here this little metal strip here. This metal strip is the only grounding point from the radio section to the main chassis. So all these bushings are electrical isolation, so that the radio has to use this ground point for the whole radio. So it's like basically like star grounding. I'm not sure if they really needed to do this stuff or if they just did it because they could, but I'm not complaining. I think it's pretty cool. Okay, so I've just glued the knobs. So basically I just sort of put a screwdriver in there to sort of open up the crack a little bit, slide some super glue down it, then clamp it really tight. Basically, I found the best way to do this with knobs is to take a zip tie, wrap it around it, and then use the pliers to sort of twist and get the zip tie truly as tight as you can possibly get it. And then I usually just stick a few extra dabs on the inner side. As you can see, there's little wells where the shaft doesn't actually go, so you can afford to get some glue on the inside if you're careful. So I'm going to leave these for about 24 hours, and then I will paint them.